Okay, hello everybody and welcome to the fourth of the Digital Classicist London Seminars 2020. I'm Paula Granados, one of the co-organizers of the seminar, and today I have with me Valeria Vitale, one of the co-organizers as well, and John Bradley, who is going to talk to us about digital prosopography and linked open data. John started his career at the University of Toronto, and he came to King's College London in 1997. And he has been working on digital humanities ever since, where he has participated in more than 30 projects, most of them related to web applications, and 6 prosopographies. Although he's officially retired, he is still active in digital humanities. So please feel free to add your questions to the live chat, and we will try to come back to them at the end of the presentation. So now I'm going to ask everybody to mute themselves, except for the presenter.
Except for me.
Yes, I'm going to move the screen to you, John.
Okay. Paula, I'd like to thank Gabriel, Valeria, and the various other people who've probably been involved in getting this seminar underway for accepting my proposal to speak to you today about the topic of the digital prosopography of the Roman Republic, what I call DPRR, as linked open data. Now let me get this set up here so it displays it properly. There we go. Hope that's okay. I'm not a classicist myself, and perhaps a proper classicist, such as one of the historian partners for DPRR listed here, would do a better job than me in presenting the classical studies issues, DPRR explorers. However, here we are in a digital classics context, and I, as a long-term member of KCL's DH academic department since 1997, as was mentioned, can sensibly be considered a digital humanist. Furthermore, both my project and personal research work is centered on humanities materials as data in the computing sense, a view that is central to the conception of DPRR and its expression as linked open data. Digital classicists have been active and often leaders in a whole range of digital humanities initiatives, and this applies to the linked open data world as well. Thus, I have this common interest with you, my audience. I like to think that both you and I are interested in how materials such as what DPRR consists of can operate effectively in the LOD, linked open data world, and this is the subject of my talk to you today. So here's my plan. First, we need to talk about the nature of the DPRR data itself, how it relates to its sources, how it relates to the ideas of factoid prosopography, and more generally, what it means to have data as the basis for a prosopography. This will have to be something of an overview, since we have other fish to fry in this session, but it's important to understand DPRR's relationship with data if we are to understand the nature of the LOD expression of it. Then we need to talk about what it means to express the DPRR data as linked open data. For DPRR, we chose to use the W3C's Resource Description Framework, RDF, and its associated technologies as a means of expression. Linked open data is arguably an invention of Tim Berners-Lee and some of his colleagues. It's worthwhile taking a moment to consider why Berners-Lee thinks LOD is significant, since its benefits, from his perspective, are somewhat different from those that I find asserted by some of the digital humanities, and it is perspective rather than this DH one that affects the design of DPRR and its RDF server. Then there's a bit of time to look at what happens when DPRR's materials are expressed in RDF. How was the DPRR materials made to be represented in RDF, and how is the server of that RDF material created? Finally, since all this work was involved in the building of DPRR and its server, and one must ask why. I think the main benefit comes out of the significance of the ability to fully open querying of the data through the use of RDF's SPARQL query language. I'll provide a few examples of this, and we'll take a few minutes to look at work being done at UCLA in California, independent of us, in true LOD style, which has taken advantage of DPRR's LOD expression. The front page of DPRR's website, which, note perversely enough, does not have the URL containing the letters DPRR in it. I'm going to turn on the pointer here. There. So here it is here. Gives a good idea what the project is all about. It's about the Roman Republic elite, and it's based on material such as the fasti that it survived. It focuses on information about their careers, offices, personal status, life dates, and family relationships, but not so much on other information that has sometimes survived about them, such as, for instance, what battles they might have fought in, what lands they owned, what letters they might have written. An important difference between this and other prosopographies in which I've been involved is that DPRR is built upon pre-existing prosopographical work done by 19th, 20th, and 21st century scholars. A part of DPRR's work is in the alignment of these pieces of scholarship. By doing this, DPRR team intended to provide a resource that makes it easier to achieve, let's call it, unified view of all of them. So what are the sources that provide DPRR's materials? The foundation is the Real Encyclopedia created by Pauli and others from the late 19th century, and is now consists of a set of books that can fill an entire bookcase. I'll be referring to this as RE. Published in the 1950s, T. Robert Broughton amassed and assembled information about people who held magistrate posts in the Roman Republic. This became a standard reference work for scholars of the period and underpinned many other prosopographical works shown here. These more recent prosopographical and semi-prosopographical works drew both on Pauli and Broughton for some of the basis for their work, and indeed DPRR, by making connections to these two fundamental studies, made it more practical to bring the prosopographical elements for all of them into alignment. The data was drawn from more than 30 secondary sources. Here are perhaps the main ones, but there are 21 others not shown here for which information was drawn as well. DPRR is a data-oriented prosopography rather than a narrative-oriented one. And we see here something about how the materials found in the sources were extracted, as it were, as data and put into a highly structured form of DPRR's relational database. On the left is a page from Broughton's Magistrates. Apologies for the poor quality of the scanned image, showing the entries he has recorded for the year 464 BC. He gives the names of the people who held the magistrate offices that year: consuls, pro-magistrates, legatis, and prefectus urbi. One can see from the highly structured nature of the presentation in Broughton that this material could easily be trained as data rather than as narrative. On the right is what DPRR shows for one of the individuals identified in Broughton as consul for that year, Spurius Furius. Here he is. We see here how much of Broughton's entry was preserved in DPRR. His name, of course, and the RE identifier, 71, largely as shown in Broughton, is used in as his display name. We see here he is identified as a patrician, and under the career section, we can see the other materials taken from this entry, that he was consul in 464 BC, for example. And DPRR also preserves Broughton's associated notes. So here are the two of them. Similar information can be found for all the other magistrates identified by Broughton, and they all appear in DPRR largely in the way shown here. There's not much information about Furius from DPRR's other sources, although note that his assertion that he has a brother comes from RE. So we don't see evidence here of much alignment work on persons, but the other materials that have a larger range of DPRR sources would make that more evident. Other sources were also harvested for prosopographical data in the same kind of way that Broughton was. As examples, here's two of them. First, the Zemeskal provides extensive information about personal relationships as they are drawn from his broad reading of the primary sources. In his public register, we can see the published register. We can see the source text followed by the relationships that he's identified. Note that the people in these relationships were identified also using the RE scheme in a manner very similar to what Broughton did. Rübke's work centered on religious offices and included the period of the empire as well as the republic. As a supplement to his written material, he provides two interlinking HTML documents, and we see here a tiny excerpt from one of them. Here again, we were able to exploit the highly structured HTML materials for Republican people to extract relevant materials for the DPRR data structures. Not all the sources provided their prosopographical materials as data in such a directly accessible fashion, but it turned out to be possible to use at least semi-automatic processing to harvest the data we wanted from many of them. One of the images I've shown you for the web page the DPRR presents for that individual will make it clear that DPRR was created as expressed as a highly structured material rather than, say, a number of narrative-oriented articles about people. In fact, DPRR's data was stored in a relational database, and my colleagues at KDL have created this substantially simplified representation of its structure. Although the actual structure is significantly more complicated than this, enough is shown here to give the general idea. At the top, we see a box for persons. This is where records for all the historical persons identified within DPRR are held. We'll see later the range of information DPRR holds about them. But here we can see that the person praenomen is recorded by choosing one of the standard praenomens used by Republican Romans. Furthermore, their identity within a particular Roman tribe is specified where that information is available. DPRR's 19th, 20th, and 21st century sources make assertions about persons, and we see 3 of the 5 kinds of assertions here. Post assertions, for example, assert that a person held a particular post at a particular time. It is this type of record that holds Broughton's assertion that Spurius held the office of consul, for example. Other kinds of assertions are also recorded. Here we see the relationship assertions between 2 people, perhaps familial, and status assertions. All assertions come from secondary sources, such as the Broughton, Ribker, Zemeskal, etc. So the sources recorded in this box are the 30 or so modern scholarly sources that DPRR drew on. Those of you familiar with factoid model that was developed at King's and applied to many of the other prosopographies in which I've been involved will see echoes of that here. DPRR's assertions are much like factoids, assertions about persons made by sources. However, here we call them assertions rather than factoids because it didn't feel appropriate for us to use the deliberately ironic name of factoid for our scholarly assertions made instead by history colleagues, as it were. We've now taken a very brief look at DPRR's base project upon which its linked open data representation was built, what was produced, and how we got there. As a result of this work, we can see that DPRR produced an open resource available for anyone to use who has access to the World Wide Web. Its materials consist of highly structured data from the Roman Republic elites, specifically about their careers, offices, personal status, life dates, and family relationships. Its sources were all 19th, 20th, and 21st century scholarly sources, which contain a significantly prosopographical component. Highly structured data in a database is not immediately compatible with the World Wide Web. Thus, because of the data nature of DPRR, we took the approach we have taken for many other similar projects and created a web application that sits between the users at browsers and the database and is built to allow users to query its data. Now that we've seen something of DPRR's structure, we need to shift the focus to DPRR's specifically linked open data. Now first, what do I mean by the term linked open data? Perhaps the idea of linked open data first became prominent when Tim Berners-Lee gave a TED talk called The Power of Linked Data in 2009. Linked data is perhaps Tim Berners-Lee's 3rd great idea. In his talk, he encouraged public institutions and scientists, he didn't seem to think of humanists, it seems, to make most of their data available freely to the public in the form so that when semantic links existed between them, they could be effectively connected together. Combining data from different sources like this is sometimes called a mashup. Berners-Lee's argument was that the act of doing mashups could reveal new things and potentially act as a stimulus for social change. Indeed, here is an example. Responding to the idea of mashups, in 2011, The Guardian newspaper did one which combined the locations of the infamous London riots of 2011 with information about social deprivation, to challenge the Prime Minister's claim at the time that the riots were not about poverty. To do a mashup requires a person to be able to interpret materials from 2 different sources in ways that allows them to be brought together in new and revealing ways. It requires the basic data from these sources to be available in a form suitable for further processing. But simply having the data from the sources is, of course, not enough. To then make the mashup actually happen requires a person, shown here in the middle, who is able to understand the sources well enough to handle them properly as semantic material. Even then, that is not enough. She or he would also need to be capable of technically manipulating the data, to understand the data formats in which the data was presented, to understand the data syntactically, and be able to work with software tools that could align and manipulate them. In the TED Talk I mentioned a moment ago, Berners-Lee claimed that the best way to support this kind of activity between data sets was, as much as possible, ensure that they are capable of linking together effectively. He said that all kinds of conceptual things should have names that start with HTTP. A paper written before the TED Talk, the Bizzer, Heath, and Berners-Lee paper shown here, explains more formally what he meant, that conceptual things should have URIs, which look exactly like URLs associated with them. This is important because it meant that people anywhere in the world with access to the internet could access them via standard web protocols. When these URIs were given to the internet, it should respond with information, data in some standard format about the thing, so that more work could be done with the result. It is important the material not appear simply for human viewing, say as PDF or in an HTML document, but to be in a data form that can be imported into software for further processing. Again, the Bizzer, Heath, and Berners-Lee paper makes this point more formally and then explicitly refers to the W3 standard RDF as this suitable format, RDF being part of Berners-Lee's second big idea, the semantic web. Finally, there was the linked part of linked data. Berners-Lee said that the data you brought back from the internet should not only be simple data like a number or a text string, but also should have relationships to other things with URI names associated with them. By following these URIs in turn, more things could be discovered. Berners-Lee claimed that the RDF framework of standards, which I've already mentioned as a product of his second great idea, the semantic web, provided an effective framework in which to build linked data. Out of the W3's embrace of semantic web emerged these three interlocking technologies, all of which have become highly developed, publicly open standards. The Resource Description Framework, RDF itself, provides a framework for expressing linked and open data. SPARQL provides a query language that allows one to explore collections of RDF statements. Think of it as parallel to SQL for relational data or XQuery for XML. And finally, the web ontology language, OWL, allows one to express semantic information about your RDF in ways that would allow digital technology to better exploit and explore the data within it. As you will see shortly, DPRR's linked open data component takes exactly the approach recommended here by Berners-Lee and the W3C, in that it is a server that is built using these three technologies. Providing DPRR materials as RDF and RDF-related formats is a substantial change from what we have done at DADH for our other open data-oriented projects. For DPRR, we still had a browser-friendly mechanism to allow users to look at the DPRR materials, but I call here our base user platform. However, DPRR as RDF clearly required a second parallel access mechanism to be added. We call this second access mechanism DPRR's RDF Server, and we'll soon be looking at what it looks like. This RDF Server is meant to take up the challenge that Berners-Lee presented about how to best represent and present linked open data. The RDF Server is a bit of an experiment. How well does Berners-Lee's RDF vision really work? Can it usefully express DPRR's materials? And once it is expressed in this way, can it actually serve as a scholarly user community by opening up new avenues for exploration? The W3C's RDF specification at first sight seems extremely simplistic, and one might well assume that it's a rather impoverished format for recording information. A body of RDF material consists of a set of statements called triples. As the name suggests, each RDF statement has three parts: a subject, a predicate, and an object. And these three names might suggest to many the semantic basis for RDF, and why the RDF triple is sometimes also called a statement. Here are 4 RDF triples in a simplified form. 3 of them are about me, and 1 is about the town of Bracebridge, in which I was born. It's important to understand that the subject and predicate components of RDF statements, the first and the second parts, are always URIs, what Berners-Lee calls names starting with HTTP, which are much like the World Wide Web's URLs. However, whereas URLs, uniform resource locators, locate documents, URIs, uniform resource identifiers, identify things. Thus, the URI, in some sense, takes on the task of representing the thing itself, rather than pointing at a web document. A URI for me represents me, rather than being a pointer to a document about me. A URI for presented at represents the idea of presenting at. It's perfectly possible to have a string or numeric constant for the third part, the object, in an RDF statement. The object of my was born in statement could simply be the text string Bracebridge. However, remembering Berners-Lee's observation that statements could not only contain information about the thing, but also act as relationships between things, we get a richer set of data if the object is instead a URI that presents these things. Thus, a richer set of data if the object part of the third statement here, Bracebridge, is the same URI as the one used as the subject for the fourth statement. And here I suggest what you might think of as a possible URI for Bracebridge, which is the VF's identifier for it. Note too, the middle part of the triple, the predicate, is always a URI in RDF. The predicates in an RDF triple often carry a significant part of the semantic meaning of a statement. Having the predicate to be a URI rather than, say, a text string, which just names the semantic component, allows the information to point to a body of information somewhere else on the internet about what the semantic connection means. In fact, the predicate as URI is one of the ways by which a collection of RDF statements connect to the world of ontologies, and hence to the formal expression of semantics for the data. Hence, a significant amount of work in making DPRR available as linked open data was involved to express it this way. The materials in DPRR's database with their semantics as open data in RDF and its related technologies, what Berners-Lee called the language of linked data. This is what we have done to provide a DPRR RDF server that operates beside the public browser-oriented web application for DPRR. In it, all principal entities in DPRRs have URIs, not only persons, but sources, offices, all the standard prenomens, and many other kinds of things beside. They all have URIs associated with them that begin with HTTP and are thus globally accessible directly over the internet. The site supports browsing of the RDF in ways we'll see in a moment, but it also provides a query mechanism so that anyone can explore this material through the RDF query language. The semantics of the data are in part represented by an OWL ontology that not only assists users to understand how the data works as RDF, but also allows things like the SPARQL query engine to provide an enhanced searching service. This all perhaps looks very positive and perhaps even interesting. However, it appears that the platform upon which it is built, RDF Triples with basic three-part statements consisting of subject, predicate, and object, seems, let us say, a mite rudimentary for materials as complex as DPRR. How can RDF Triples provide a rich enough framework to deal with DPRR's needs? Ideally, one should look at how one maps all of DPRR's database structures onto RDF Triples, but we have no time for that. Instead, I'll give you a general idea by showing what RDF Triples come out of this particular page from DPRR's web application for Marcus Aurelius RE117. The same process works pretty well for all the other pages as well. You will recall that RDF statements are made up of triples. Here in red are the few triples to get us started. First, the ID shown here for Marcus Aurelius, AEMI 0739, is the subject, must be asserted to be a person. In ontological terminology, to be a member of the person class. Other classes for DPRR data include assertions, sources, prenomens, and as we shall see shortly, many more. Second, and also not shown explicitly on this page, but recorded in the DPRR data set, is an assertion that this person is male. He has a display name, which is asserted using the predicate has name, and is represented by a string of characters, as is shown here. He is a patrician, and this is specified through the predicate is patrician, and having the value true. And then we have somewhat more complex bits. He's a father of another person, Lucas Aemilius. Here we're showing the use of RDF statement to link two of DPRR's persons together through the father of connection, and he is a consul, asserted here with the predicate held office of. The last two assertions that are shown here could be represented in the same kind of way. Berners-Lee asserted that to enable open and linked data, one could use URIs to name things. And this person, which inside the DPRR team is called, this string AEMI 0739, which is called the DPRR ID, is not by itself a URI. So here we can see the URI that was actually used for Marcus Aurelius. We've added another triple that provides this DPRR ID as AEMI 0739. As we've pointed out, RDF statements components are often URIs, so we have mapped all the components except what I call constant values, such as his name, to URIs. Note that although almost all the URIs start with Roman Republic ac.uk, and in some sense therefore belong to DPRR, not all do. The ISA statement at the beginning, in the first triple we've shown, has a URI from the www3c.org organization, since they defined what is meant to be an ISA relationship. In fact, we're only seeing a subset of all the triples we really have for Marcus Aurelius, and the full set, there are other non-DPRR URIs used as well. Although the URIs represent what RDF linked data is really like, it becomes too cumbersome to create for human beings to interpret the triples expressed as full URI identifiers. Thus, most RDF notations, a scheme called prefix name is used to represent them, and it's shown here. At the front of the set of data, one provides a set of prefix statements that tells a computing system how to map the prefix part of the name, DPRR person, RDF type, vocab, into a full URI. So far, so good. However, an important part of the materials displayed on Marcus Aurelius' page has not yet been dealt with these bits of RDF. For the father of relationship, shown here, we have a source for the assertion, Zemesca, which we haven't represented in RDF. The DPRR data doesn't only say that there was a father-son relationship here, but also tells us what the secondary source was that tells us about it. Similarly, for the career assertions, we have not only the source for the assertion, but the associated date as well. His consulship was in the year 255 BC. How can this information about an assertion be represented in an RDF triple? There's no room for this information about the RDF triple in these simple tripartite statements themselves. We deal with the enriching of these assertions by a process similar to what RDF terminology is called reification. And I'll show you how this works next. Instead of asserting relations in career post as simple triples, RDF turns these assertions into more complex entities in their own right, with their own URIs. Here we see a slightly simplified version of the triples for the father of relationship, they are there, and the consulship post. They're shown in what's called RDF turtle notation, which is simple enough to follow without needing, I hope, any detailed explanation. For the father of relationship, for example, the assertion gets its own URI, and then 5 RDF statements are made referencing it. The first asserts that this assertion 1614 is of type relationship assertion. The second tells us this relationship assertion is a father of relationship. The third gives the father as on Marcus Aurelius, that's him. And the fourth specifies he's father of this person with code 826, Lucius Aemilius. And the fifth specifies the secondary source, provided this is the Mescal 2009. Similar mechanism is used for the post assertion for consulship. Here the statements establish a post assertion and then connect it to the person for the consul office here, and specifies the date and gives the sources Broughton. Putting the materials about Marcus Aurelius together with 2 of the several assertions made about him allows us to create this visualization. In the top right corner is the list of RDF statements in what is called turtle format that we have shown you already. The rest of the slide shows what might be called a graph representation of the same data. Each RDF triple is shown by making the subject and object parts boxes, person, DPRR person, and showing the middle predicate parts as lines with labels that connect them. Mathematicians call this type of representation a graph, and the mathematicians that works on boxes or nodes and lines between them, the links, called graph theory. Each link type and most boxes or nodes are URIs that could refer to servers located elsewhere in the world. Thus, it's because of this kind of visualization that one says that RDF can be represented as graphs, and the web of data that might span servers around the world It's called the global graph. RDF puts no limits on what RDF statements can be associated with any node. Thus, it would certainly be possible to arbitrarily create quite entirely different kinds of information about each person in a single set of RDF statements, sort of a grab bag. And no RDF system would ever complain. However, it would be difficult for users to derive much overall significance from such an inconsistent semantic graph. This is where the ontology for DPRR comes in. Ontologies are declarations rather than rules. They describe a data set rather than restricting it. And if the description is accurate, they can facilitate both human understanding and machine manipulation of a complex set of data. Thus, an ontology describing DPRR's data was developed using RDF's OWL ontology language to supplement the RDF data itself. DPRR's data comes in a relational database model, which by its very nature introduces discipline into the data it records, and therefore allows for an overarching structure and meaning to emerge. Thus, it is an appropriate task to create a rudimentary OWL ontology to accompany the data for the DPRR dataset. DPRR's ontology is described in more detail on this webpage. Here are two representations of DPRR's ontology, both of which are found with the accompanying commentary on this page. To the left, we see a hierarchical representation of OWL's classes that are in DPRR's ontology. They organize the classes into a kind of relationship called an OWL subclass relationships. Thus, for example, we can see the 5 classes indented under the class assertion, meaning that, for example, a post assertion is a kind of assertion. We don't have time to say more about this representation for DPRR's OWL ontology, but the kind of relationship can be exploited by software, and that's why it's particularly useful to provide it. The larger diagram on the right shows how the types of predicates in RDF triples can semantically collect the classes together. It's a handcrafted diagram, and I wish I'd been able to lay it out in a more understandable way. After an admittedly brief look around, I couldn't find software that created a more understandable diagram than this. The boxes represent the classes of data. Here's the box for DPRR's persons, and here's the one for status assertions, for example. The double-lined arrows, this or this or this, connect together subclasses. So this one shows that the class sex is a kind of authority list in DPRR, and that the tribe assertion is a kind of assertion. The single-lined arrows connect classes too, but this time by the RDF predicates, middle part of the RDF triple that connect them. I've highlighted here in red the connection between assertion and person that is provided by the is-about-person predicate that we saw earlier. Similarly, recall that assertions are drawn from secondary sources that DPRR processed. The other red highlighted arrow with its label down here shows that which source the assertion comes from. As you can doubtless see, it's not easy to interpret this diagram, but it is possible to use it with accompanying commentary I've developed, that I mentioned earlier, to develop an understanding of how DPRR's data is structured. So now that we've seen how DPRR's data has been mapped to RDF, and how the reification-like approach allows RDF triples to represent rather complex data like that in DPRR, we've also seen how RDF can be structured overall to reflect the structure of the database upon which it is built, and how the ontology for DPRR facilitates this structuring. Now we see how this RDF data is being delivered to a user community through the provision of an RDF server, shown here, for DPRR. As this diagram suggests, the RDF server runs as sort of a parallel server to the traditional browser-friendly DPRR web apps. All requests with URL paths that begin RDF are passed to the RDF server. All other requests go to the main server. The traditional browser web app was handcrafted by the technical team at KDL, and as we saw earlier, was built to reflect the nature of the data that DPRR turns. The whole story is somewhat more complex than is shown here, but essentially it pulls the material it displays to the user from the database that was created by the project. The RDF server runs from RDF statements that has been created from the database. The triples are created as an essentially automatic process, and the tool to do this is D2RQ. These triples, about 500,000 of them, are loaded into a handcrafted with a handcrafted DPRR ontology into a piece of software called Triple Store, which acts as a kind of RDF database storage mechanism. We've used the RDF4J toolkit to create the RDF server using the RDF components for the Triple Store. And we funded it then with what the RDF folks call the workbench, a tool which can be connected to any set of RDF data, which allows the user to explore it. We've removed parts of RDF's workbench that allows the data to be changed, and we've supplemented it in various relatively minor ways that I won't go into here. Now that we've considered how DPR got to the point it is time to take a look at the experience of using DPR's open data RDF materials, what it is like to use them, and what might they offer as a benefit to user. Starting at the beginning, if we simply give the RDF server's base URL, which is http://RomanRepublic.ac.uk/RDF, to our browser, what do we see? This front page presents us with one of the tools that the RDF server makes available, the Workbench's SPARQL query mechanism for the RDF data. And we'll look at that briefly in a moment. At some point, however, you may wish to look at the server yourself. Allow me then to direct you to two places on the first display that might help you get started. The left area has a small menu of tools that the server provides. You can see here the query tool listed. That's the one we're seeing here, and we'll look briefly at some of the others shortly. Your browsing of the data is likely to come out of interaction with these tools. Notice too that the top right area has links to documentation about the RDF server. The first item here points to the browser-oriented DPRR web application, but if you click on the second item there, DPRR RDF documentation, we jump to the pages that document DPRR's RDF materials. And the beginning of the first page is shown here. More documentation is available from the tabs shown here and shown highlighted here by the red box. And in particular, the DPRR ontology describes it. It's necessary to understand the ontology if you plan to do serious work here. Now that we've had the first sight of the RDF server, you can see that we've created it. You will see we've created it to match Tim Berners-Lee's vision of an RDF-driven linked data and semantic web world. How well does it live up to that vision? Well, first, all the data in DPRR's RDF data, not just persons, but all data associated with all the boxes we saw in the ontology's relationship diagram, have URIs attached to them. If you give any of these URIs to the net, they will find their way to the RDF server, and they will respond by delivering information back in RDF about that entry. Here we used our browser to request data for the DPRR person by entering the person's URI, there it is there, as a URL into the web browser. This happens to be our old friend Marcus Aurelius, who I used as an example a little bit ago. The server responds to this request by delivering all the RDF statements that it has that refer to DPRR person 3739. It shows them to us in a 3-column table using the RDF4J's Explore mechanism, which wraps a light layer of HTML around the RDF so it displays well in the browser. Note that the entities are blue and underlined, so you can click on any of them to shift the focus to a particular entity. For example, you can see he's associated with 2 relationship assertions down here at the bottom. By clicking on either of their URIs, shown here, you jump to focus on those entries, allowing you to see more about them. By starting somewhere like this person, one could follow a sequence of displayed URIs as links to anywhere else in the DPRR dataset, hence the name Explore for this component of the server. We've just seen the server respond with a display that is suitable for people to view as a browser. However, as we shall see shortly, it is often useful to have the data be presented plain rather than wrapped in HTML for browser display, for further processing by other pieces of software, say. So one can use the same URI, but request that the result be in plain RDF in a range of different RDF formats, including its turtle format shown here, or other standard formats such as XML or JSON-based ones. Programming language like Python, which has modules that can interpret RDF data and modules that can issue a URL to the World Wide Web and receive something back, can thus work directly with this data. We see examples of this in a few minutes. For me, the most interesting potential benefit from DPRR's RDF comes from the server's SPARQL query mechanism. SPARQL is one of the suite of standards developed by W3C within the RDF development framework. SPARQL, the DPRR RDF server, supports the most recent version, 1.1, of the query language. Like many other formal languages, it takes some work to understand the formalisms that make up the language so you can use it effectively. And there's no time to go any of that here, but a few examples of SPARQL queries with a very brief explanation of what they are requesting might suffice to give you the general idea. Truth be told, I'm a little nervous about what follows in my talk because it is likely to appear to be a bit of a whirlwind to some of you. My intent is to give you all a sense of the range of queries that can be run against this data, and some sense, albeit at a superficial level, what it takes to make them work. Remember Berners-Lee person involved in making a mashup. They needed both subject knowledge and rather sophisticated technical knowledge to achieve things. I hope some of this emerges from this part of the talk. Of course, the other browser-oriented front end from DPRR also provides access to a data through a kind of query mechanism. Here is the top of its person search screen. The form goes beyond what we see in this screen capture. Below, there's a significant number of options relating to careers that can be chosen. And users could choose to constrain, say, by choosing to focus on novices who were also held the office of proconsul. The RDF server provides through SPARQL a mechanism that also allows for searches to be carried out against this data, and here's the screen for it. The contrast is substantial in style, however. Note the different expectations that are embedded into its design. Instead of choosing from a set of given options that can lead a user in the possible directions, one must type a query into the query box and push the execute button to have the server execute it. To create the query, one must need to understand SPARQL well to express the query correctly. Further, one needs to understand the structure of the data well enough that the patterns you give in your query can actually occur in the data. And this is quite an intellectual burden. However, the benefits you'll be seeing in a couple of minutes. Let's work through a first example. Suppose one wants to know all the secondary sources that were used by DPRR. The web browser's faceted search mechanism focuses on certain types of queries only, and through none of them is it possible to get a complete list of what the sources are that were used. Before the SPARQL query can be created, we need to understand how the RDF structures handle secondary sources. If you go to the types display, not really shown here, we can see an entity type vocab secondary source listed. And if you click on that, we see this, that the first block of triples are related to what the ontology has to say about the entity. However, below this, and highlighted in red, we see the beginning of the list of entities identified as secondary sources. And we can scroll down to see all of them. Choosing one of these at random, well, first, we can redirect the Explorer to show us all the RDF triples it has about the source, this first one. Again, some of the triples at the top come from the ontology. However, we can see one triple in particular, this one, with the predicate vocab has vocab biblio that specifies a bibliographic entry for this source. If we looked at DPRR's ontology, we could see that all secondary sources have a triple of this kind. By focusing on these, we get a complete list of sources in a form that is understandable to us. Here's a SPARQL query that does exactly this. Again, there's not any time for proper tutorial on how this is written. Some sense of overview is all we can give. This query could have been typed in the form shown here directly, although I actually typed it in somewhere else and cut and pasted it into here. And the key bit is where the where clause, highlighted side by this red bracket that I've added, we can see there are two triple patterns being given. The first one says we want to select entities here called $source that are secondary sources.
Sorry, John, just to let you know quickly, we need to leave some time for discussion. So
okay, I'll try to wrap up quite quickly. Let's not worry too much about this then, about how this actually works. Let's quickly move to see what things look like. So, here's the query that shows the result of that, showing the URIs for the sources and that extended description that allows us to understand what the things are. Suppose we were interested in this one here, the Iggenshorst source. How many sources come from it? Clicking on the URI from that source, we can go and see it described, and we can see the assertions listed down here at the bottom. Clearly, we can change the query so that perhaps we can look at all the sources and get a count of the number of assertions that come from all of them. That's what I've done in this slightly extended query. And here we have the example that shows the result of this, showing for the different sources down here with their extended names, the count of the number of assertions that come from each of them. This is the top part, and this is the one at the bottom list, which shows when the sources contributed only 2. Now, you can get this data you can get this material as data rather than as a presentation of this kind in CVS format. And from there, we could load it into a spreadsheet, say, to do further processing. So I've done that here. I've fetched the same data from the same query, almost the same query, and used Excel spreadsheet to present it as a graph, as a pie chart. This is the kind of thing, this is, I think, one of the advantages of having data, that you can do more work on it rather than just being obliged to simply look at it. Probably useful to go and look very quickly at a couple of other examples. So let's skip this one for the moment. We don't have time to go through this. Here's a query, for example, that looks at, oh dear, what does this one look at? I've forgotten. It's embarrassing here. Oh yes, that looks at all posts that were associated with the province of Asia, and by people who had the status of equi. And as it turned out, I was not interested in the ones who had the legatus offices attached to Asia. I wanted to see all the offices that these people held that were connected with Asia. Here's the result. And yeah, and let's look at one more quick example: offices held by sons of consuls. So father was a consul. There were 3 types of sons recorded. This connects them to the 3 different types of sons, and this selects the offices held by those sons. So these people, the sons of fathers, what sort of offices did they manage to get to? And here's his beginning of the list for that. Once again, we can change the query so that it shows you the count of the number of different types of offices that they held. Not surprisingly, many of the sons became consuls themselves. Here's offices held by women. And here's the list of them down the side here, and the date for which these particular women held these offices. And finally, an example showing consuls by tribe. The consuls, sometimes we had data that indicated which consuls belonged in which particular tribe, Roman tribe. And here we plotted the tribes down this side for the consuls, and the date across the bottom to show the different consuls that people held. This is part of the timeline demo that I provided as an example here. Now, I hear you saying, this is all very nice, but it requires me to know a lot of technical stuff if I wish to do this kind of thing myself. Seemingly, I need to know this highly formal language, SPARQL. I need to know in detail how DPRR works in RDF. I need to know Python for this particular example. I need to know Google Graphs for this particular example. Perhaps the timeline graph plots the consuls against the year, but this is not actually a very interesting result. And you might be right. Provide you with an example that would properly interest a historian of the Roman Republic, but would require me to be an historian myself, and I'm not, as well as having these technical abilities. So, is anyone going to be out there in this world to actually able to do this sort of thing? Well, shortly after we produced the RDF server, we got out of the blue, as it were, email from some folks at UCLA who were actually doing exactly this kind of thing. One of the members of the project, headed by Professor Chris Johansson from UCLA's Department of Classics, contacted me with a question. And they wanted to create visualizations of Rome's Rostra during funerals of prominent individuals in the Roman Republic. And they used DPRR to find out who the ancestors were, so that they could indicate what tokens actors who presented these ancestors would appear in, to get some sense of what the thing might look like. Here's a screen of one of the visualizations that they made. You can go to this URL if you want to see all the other ones they've done. Johansson was interested enough that he decided to show this to his students and created a project called the Shape of Roman History Project, whose homepage is shown here. There's the URL for it at the bottom. The shot of the DPRR server here was his idea, not mine. The students took the approach presented in my timeline Python script and produced something like 50 charts. I think some of their charts could have been produced by the less technically demanding approach of fetching the data from the query as a CVS file, in the way that I showed you for the Excel chart. I've shown 2 of you here. This one shows the number of consuls who had wife who was also a daughter of another consul, distributed by year. And the second is a social network analysis graph showing family relationships. And indeed, a very broad range of stuff could be plotted by these folk. It's important to realize this was carried out without any active support from myself or anyone else on the DPRR team. They can, on their own, make use of the RDF server for original ways like this. So I think there's a reasonable chance that others elsewhere might be able to do this. And indeed, we used to teach in our department our MA students, both RDF, SPARQL, and structured data, and Python. And some of the students who had a humanities background told me themselves they came away with the sense that they had sufficient skills to be able to do useful work. So with a proper commitment, we think this is possible to do. The server continues to be an experiment. The particular situation that arose in DPR made it possible to create it, and I'm indebted to various persons that made this situation arise. I don't know what practical outcomes will come from the existence of it, but it does test out whether this kind of object is actually useful. Indeed, a somewhat similar situation has arisen for an entirely separate prosopography, our medieval Scotland prosopography project, POMS, and with the support of the historians in it projects, I've been able to create a second RDF server for that data too. Lightning has indeed struck twice. So I have many people to thank, and that includes you, my very tolerant listeners today. Time for questions at last.
Okay, that was brilliant. Thank you very much, John. We're a bit short on time, so unless Valeria has a question, I think we can look. Yes. Mm-hmm.
No. Start with the public. I'll hold my horses.
Okay. Then we will start with the public, and we have a question from Charlotte Rocher, who asked, "How does the DPRR ontology map onto others, such as RBO?"
Well, the purpose of it wasn't so much to do that. I mean, that's one of these other D8 views, but it does actually map to CDOC-CRM, and there's specific reference to it in the ontology saying this bit connects to the that part there. It doesn't all map because CDOC-CRM isn't really about ontologies. So an important, not about ontologies, about prosopographies. So it wasn't entirely trivial to make it work for all the components that are in there. The people, for example, in CDOC-CRM are primarily people who work with material in museum collections, who are the curators, who are the people who maintain the objects, who are the collectors, those kind of people. And that we don't have that kind of data here, so we couldn't connect with various parts. But in places where we could, we did.
That is really interesting, and it fits nicely with another of the questions that we had with where Sanka Bird was asking the same about CDOC-CRM.
Yeah. So, I'd be interested in exploring further connections for those of you who know CDOC-CRM better than I do. So if anyone wants to dig into this and find out, we could update the ontology and make better connections that way, and I'd be very glad to do that.
Okay, and one more question from Charlotte, who asks, can biblio entries also connect to VF? They
could. The problem, as Charlotte will understand, is time. Projects, we never get enough money for these projects. I mean, as much as we're thankful to the AHRC for funding it, we're not so thankful that they never give us as much money as the projects actually need. So we didn't have time to direct our researchers to make those connections, but they could have been made. Furthermore, because the data is in the worldwide, is out there in the web, rather than tied up inside a database, say, since it's out there public, other people could express collections of RDF statements that connect them, pointing at individuals inside our collection on one side and pointing on the other side to VIF people, and maintain a separate connection, which they would own, that makes those connections themselves. And they could publish them entirely separately. That's the global graph idea, which is central to RDF.
Okay, we got some more questions from Georgios Solakis, who asks, well, he thanks for the presentation, and he asks how DPRR ontology is handling uncertain relationships. For example, person X is the husband or the son of person Y. And he gives one more example, or person Z may be a patrician. Is there maybe a patrician a subclass of patrician? Thank you.
These are good ideas, I mean, but we didn't do them. I have some excuse in that don't forget that our material comes directly from primary sources. Our folks were not involved in interpreting what the primary sources say. Instead, we're representing what the secondary sources say. Someone else has already done the interpretation at that level. So if Broughton says this person's a patrician, or RE says this person's a patrician, we've recorded that. And we're not exactly passing the buck on the responsibility of that because it's in our data, but it's not our considered prosopographical thoughts that make that assertion says it's because someone else has already made it. I like the idea that you have the maybe sort of thing. I don't think subclass is quite the right way to deal with that, but this whole question of definiteness of assertions becomes an issue with our factoid-based model, which I said this isn't quite one of those, this particular one. And there we don't have a completely satisfactory for that problem there either. We often have a flag that says we think this assertion is uncertain, and we often allow people to put notes in so they can explain what the nature of the uncertainty is. That's about the most we've been able to do. If you have better ideas, please email me or talk to me about them. I'd be glad to hear them.
Okay, and one more question from Georgios. He's asking, is the turtle or titles of DPRR available for downloading in an online repository?
Unfortunately, it's not. We'd like to make them available. For the Scottish Prosopography, for example, we have them all set up and the data is downloadable. But at the moment, there's an issue which we haven't yet sorted out to make these triples available. If you specifically wanted it, you can email me again. Getting a lot of emails from you, maybe, Georgios. And I could ask them if I could send them to you. And I'd be perfectly glad to do that.
That would be great. And again, Sanka is asking, are all the prosopographies you have worked on as well structured, or do you have to work on only free natural language?
Well, my sort of specialty was structured prosopography. So those are the kinds of things that I did essentially all the time. And once you do a couple, you get known for that sort of thing. So other projects sort of came to me from other people to work on this highly structured approach. So they're all that way. And I realized that's sort of a sub-community of what prosopography might be about. But those are the ones that I have personally worked on. So.
Okay, so I think we are not getting any more questions from
Maybe I can ask something to John?
Of course.
Yep.
So, John, to what extent do you think that the work that you've done on this prosopography can be recycled in other prosopographies? How much this is time and culture specific, and how much of this can be used as a model, let's say, for other prosopographies, you think?
That's a very interesting question. The RE initiative, way back, the Pauli initiative, of course, was one of those, at that time, late Victorian times and later, where people thought of doing data for eternity. They thought they produced the final definitive answer on things. And of course, that's no longer the way we think. So I doubt very much if we can reasonably expect that someone would still be consulting with this prosopography, except maybe as a curiosity, say, 50 years from now, maybe even only 20 years from now. On the other hand, the data is out there publicly available. As long as we keep the RDF server available, anyone can link to it. Anyone can produce their own sets of separate data that connects to it. And it's possible to provide nature's interaction that cross between these different connections. So I think other people could enrich or improve this data. Gabby's initiative, name escapes me at the moment. Snap, exactly. Thank you. Could harvest data from here and provide another sort of central place where some part of the data exists. But that doesn't mean that our data still doesn't exist out there to be pointed at and interacted with. And queries could cross-connect between these different things. So I think there's a lot of potential. The open global graph nature of this, I think, is a really interesting potential, which we haven't yet really very well explored because.
Yeah. Thank you.
Okay. So I think we don't have more questions. I'm going to thank John very much for your presentation. It was really interesting to see all the process to the generation of the turtle files and then how to put them in the server online. I was also curious about whether you got some feedback from users that are emailing you through the repository, or apart from the projects that you mentioned. Do you have any?
We never get feedback for any of them.
Okay.
Of my 30 projects, I could probably count on 2 hands the number of pieces of feedback we've got. Please give us feedback. We're glad to have it. That's not because we don't want it. It's just that people don't. They're busy doing other things. And it was interesting that the folks from UCLA got in touch with us, and I have no idea whether other people are making use of it or not.
Exactly.
For the other prosopography, there's a community of people ready to use it, and I think there'll be some discussions going on among them. I'm going to workshop with them about that. This is the New Scotland one, and that may provide a richer type of interaction. I hope there is more, and I'm glad to have more here too. If you folks choose to speak up and tell us what you think, so please do.
We have one more question. Eponymous says, does the database have conflicting assertions about individuals?
It's not so much here because, of course, they're secondary sources. So the secondary source people mostly sort of smooth those out. For Broughton, for example, says, I think that this person was consul in this year, this time, and puts a note in saying what other possibilities there might be. But we went with the Broughton main declaration, as people who use the Broughton resource do. For the other prosopographies, the factoid ones, which are primary sources, yes, we do accept contradictions. Factoids can contradict each other. And these could too, but I don't think they do very much.
Okay, then we can finish with one comment from Charlotte, who says, very many thanks. I learned a lot and realized what I had not understood before. So I think it's really good comment to finish today. And I hope
you folks get back to me so I can find you things that I didn't understand.
And we also finish with a request. Please get back to John if you use the resource. It would be great to hear your feedback. So I'm going to end the broadcast now and say thank you to everybody who joined us live today. And please come back next Friday again for the next seminar.
Bye-bye. Bye-bye all.
Bye, everybody.
Bye, thank you.